Swayam Prabha. Digital India. Educated India.
Welcome to Module D, Lecture 4. In this lecture also, we shall continue our discussion about analysis of basic freeway and multi-lane segments as per Highway Capacity Manual 2016. And to have a quick recap, what we discussed in lecture 3 is how the level of service can be defined for multi-lane highway segments and also for freeways, description of different levels of service starting from A to F, then the LOS criteria, what are the density thresholds that are used to define the LOS, and what are the steps, broadly 6 steps for the operational analysis of freeways and multi-lane highways segments. Then step 1 and step 2, the computational steps we discussed. To continue with that, let us once again look at these 6 steps. We start with the input data, where we have geometric data, demand volume and measured free flow service, if we can do field measurement, and that of course, that is desirable. If we cannot do that, then we have to estimate and adjust the free flow speed. So, how we can do several adjustments may be necessary separately for freeway segments and multi-lane highway segments. So, these 2 steps, first the step 2A, estimation of FFS, and step 2B, adjustment of further adjustment of FFS based on local conditions, that much we discuss. So, we now continue the same discussion. Now, we take step 3. Step 3 again, estimate and adjust capacity. So, there are 2 components, estimation of capacity and adjustment of capacity. First, 3A, estimation of capacity. Base capacity value for different free flow speed values can be obtained for basic freeway segments and multi-lane highway segments using table 1, what I have already shown earlier. You can see that what are the free flow speed values, and then corresponding 2 columns, one for freeway segments, another for multi-lane highway segments, which I produced it here in this module as table 4.1. Basically, that is exhibit 12.4 of Highway Capacity Manual 2016. So, once the FFS values are known or FFS value is known for a given segment, and we know whether it is multi-lane highway segment or it is a freeway segment, accordingly from table 4.1 or exhibit 12.4 of Highway Capacity Manual, we can select the values. Now, because of the ability to interpolate between different free flow segment values, you know that the values were given at 5 mile per hour interval. So, we can do interpolation. So, we can take what is the value for x, and then next level maybe x plus 1, what is that level, and then 2 free flow speed values, what are the corresponding capacities, and we can interpolate it if required. So, that is one way we can do it. Alternatively, we can use equation 4.6 and 4.7, which was again mentioned, these were mentioned earlier, but again I have mentioned it here, that we can directly use these equations. This is for basic freeway segments and this is for multi-lane highway segments. So, once we know the adjusted free flow speeds, then we can use either equation, the first one or the second one as appropriate, depending on whether the segment is basic freeway segment or multi-lane highway segment. We can also calculate the capacity value. So, we can one way either take it from a table or exhibit and then interpolate it, or we can directly calculate it. Then next step 3b, we have to do further adjustment of capacity, and these adjustments are to suit to the local condition or prevailing condition, because capacity of a basic freeway need to be adjusted further to account for impact of several factors. I have mentioned only a few here. For example, adverse weather, driver population, somewhere there could be side distance, poor side distance, and which may impact the overall flow and the capacity. Sometimes it may be poor pavement condition and sometimes even other factors. So, or say combination of various influences. So, therefore, whatever capacity we have got, we multiply it by an appropriate factor, what is called as capacity adjustment factor. Sometimes this may be a single value, sometimes there may be multiple values, there are so many things, but we get that factor or those factors, combination of factors, and then accordingly get the C adjusted or the adjusted capacity of segment as per prevailing condition. Of course, similar kind of adjustment may not be able to do for multi-lane highways, since no empirical research exists for its application. Then the step 4. So, we have gone to up to step 4, step 1, step 2, step 3, step 4 then in adjust demand volumes. Now, why we are doing these steps? Because speed flow curves and parameters of table 2, which again I have shown in earlier lecture, shown as table 4.2, wherever 4.1 and 4.2 are shown together, how the basic capacity values we are getting, and then what are the further adjustment factors, which are actually the adjustments are exhibit 12.6 of Highway Capacity Manual 2016. These are based on flow rates in equivalent passenger car per hour. So, the unit what was used, passenger car hour per lane. So, now we then need to therefore adjust this volume whatever we have got so far to convert them to equivalent passenger car per hour per lane, and also the capacity is expressed considering the 15-minute flow rate. So, we need to take care of that. So, the peak hour factor also will come. So, how we are converting the demand volume under prevailing condition to equivalent demand flow rate under base conditions BP with the help of peak hour factor, also the number of lanes, because we need to express it on passenger car per hour per lane. So, that N is number of lane, and FHV, this is the correction factor to account for heavy vehicle population that are there in the traffic stream, because the base condition assumes all are passenger car homogeneous. So, we need not the vehicle, but equivalency, some kind of equivalence we have to use for heavy vehicles, and the appropriate adjustment factor for that FHB to account for that heavy vehicle proportion in the traffic stream. So, the peak hour factor, as I said earlier, peak hour factor represents variation in traffic flow within an hour, and observations of traffic flow consistently indicate that flow rates found in peak 15-minute within an hour are generally not sustained throughout the entire hour. And as I said earlier, that the capacity is expressed and the flow rates are expressed as 15-minute volume expressed into equivalent hourly flow rate. So, the peak hour factor once we are applying, then this accounts for this phenomena which is said here. And on freeways, typical PHF ranges from 0.85 to 0.98, and on multi-lane highway the range is 0.75 to 0.95 as given in highway capacity manual. So, based on this fact we can apply a particular pH value to take care of the 15-minute hourly flow rate. Then the adjustment for heavy vehicle, that is the next one, FHV. That FHV, as I said, all heavy vehicles are classified as single unit truck or truck trailers, TTs, so SUTs or TT. Recreational vehicle and buses are taken as considered as SUT. Therefore, the heavy vehicle adjustment factor is computed by combining two heavy vehicle classes that are added to get an overall truck percentage PT. So, take that PT is the proportion of SUTs and TTs in the traffic stream, total share in decimal, and then ET is the passenger car equivalent of one heavy vehicle, what we are considering together, and that is obviously the effect of heavy vehicle will depend on the terrain condition also. So, for level terrain that PC is taken as 2, and for rolling terrain the value is taken as 3. So, that is what is the value of ET appropriately we can take, PT we know. So, we can calculate FHV, and then the number of lanes already we know. So, we can now get the value of Vp, which is the demand flow rate under equivalent base condition. Now, once we have done that, we know the capacity, we know the volume. So, the first thing is to check whether our volume to capacity ratio is greater than 1. Why we need to do that? Because you know that if it is greater than 1, then straight away we can say that the level of service is F. That is the purpose. So, at this point the demand volume has been converted to a demand flow rate in passenger car per hour per lane under equivalent base condition, and the demand rate therefore must be compared with the base capacity of basic freeway or multi-lane segment, as I said earlier. And if the demand exceeds capacity, that means volume to capacity ratio is greater than 1, then straight away we can say the LOS is F. If it is not so, if the demand is less than the capacity, then we have to go to the next step, which is step 5. Here with known speed and the flow, we have to calculate the density. So, to calculate the speed, we know the flow, we know the speed flow equation. These equations also I have mentioned earlier, but I have reproduced it here. You know there is a up to break point, the speed is free flow speed, obviously free flow speed adjusted for the prevailing condition. So, the directly we can use this value, and between break point and the capacity, if it is in that range, which is curve follows parabola, and there all these value equation can be used, and what could be the value of A for multi-lane highways and what could be the value of A for freeways, all these are given in table 4.2. So, you can go back or you can go to the appropriate exhibit in highway capacity manual, and here knowing the Vp, knowing the Bp and free flow speed adjusted, knowing the capacity, everything is known. So, we can actually calculate the density once the speed is known and the V p is known. So, this equation will give you the speed. So, the speed is known and vehicle volume is known, equivalent hourly flow rate in PCU or passenger car per hour per lane is known. So, we can simply flow by speed, we can get the density. Now, the density is known. Now, step 6. So, we can easily now determine the capacity, because this table also is familiar, you are familiar with this table. So, you know that there are different ranges, say for example, density less than 11 means A, greater than 11 up to 18 it is B, greater than 18 to up to 26 it is C, and so on. So, now the calculated density whatever we have got, we will see here it corresponds to what level of service. So, accordingly we will say what is the LOS. Now, let us look at the applications to understand it even better. So, we will pick up two examples quickly. One is the freeway segment, another example with multi-lane highway segment. First, the freeway segment. Find the expected LOS for a 4-lane freeway, 2 lane in each direction. Every information is important. During the worst 15 minute of peak hour with following characteristics: lane width is 11 feet, right side shoulder clearance 2 feet, commuter traffic is regular class, peak hour factor is 0.92, peak hour peak direction traffic volume, this is going to be critical, that is the demand volume 2000 vehicle per hour. Notice that it is vehicle per hour, not in passenger car per hour per lane. Facility operates under ideal condition, that means no other adjustment will happen for the capacity once we calculate the capacity. Total ram density is 4 rams per mile and traffic composition includes 5% of the truck. So, that will matter when we convert this vehicle into passenger car per hour per lane. It is level terrain and 1 cloverleaf interchange per mile. So, that is what is the thing. So, input data, all input data are specified, all inputs we require are there. Now, we apply this equation 4.2 because it is the freeway segment. So, correction with respect to LW, lane width, but lane width here what will be the value? Lane width, it is 11 to 12, it is 1.9. What was the lane width? 11 feet. So, that is why we take this correction factor as 1.9 mile per hour, reduction will happen. Then total ram density, this also we can right side lateral clearance we can take based on the number of lanes, the table is produced here. So, you can come to this, and adjustment for lane 11 feet lane is 1.9 meter, adjustment for right side lateral clearance for 2 feet, clearance of freeway with 2 lane in each direction, that is 2.4 mile per hour. So, that much adjustment we have to do. Total ram density is 4 rams per mile, that is what we have get. Okay. And so, that correction is also applied. So, we can actually calculate the FFS. So, 75.4, why 75.4? Because that is what is the default values, that is what we have taken. Please connect it to my earlier lecture. I says above 75 mile per hour, right, that is where the equation starts, or the model or the prediction model is developed beyond that. So, and the default value precisely 75.4. So, use this 75.4 minus 1.9 minus 2.4 and minus 3.22 into TRD to the power 0.84 is 3.2. So, 60.8 mile per hour. So, this is my FFS, taking BFFS as 75.4 default values for freeways. Now, the facility is operating under ideal condition, that is what has been told earlier also. So, facility operates under ideal condition. So, no further local adjustment is necessary. So, the adjusted FFS is also same as FFS, that is 60.8 mile per hour. Then once we know that it is 60.8 mile per hour, we can go to this table. We know the value of capacity for basic freeway segment for 60 is 2300 and for 65 it is 2350. So, we can interpolate it for the value 60.8. That interpolation has been done and then you get a value of 2308. Alternatively, I told that we can use the capacity equation. So, we have also done that here, both we have shown here. So, you can do that, take the FFS adjusted value 60.8 and you exactly get AR also again 2308. You just see both cases you get the same value. And for ideal condition again there is no further adjustment to capacity. So, the capacity adjustment factor is 1, CF is 1. So, adjusted capacity is also same as the calculated capacity under ideal condition to 2308. Now, the demand volume need to be adjusted. So, we have the value of V that we know 2000 vehicle per hour, but peak hour factor is given as 0.92. We know there are 2 lanes on each side and FHV that we have to get. To calculate FHV we use this formula. I have mentioned this earlier. ET value is given as 2 and PT is 5% 0.05. So, if you calculate the value of FHV and now with the known calculated value of FHV n as 2 and peak hour factor as 0.92, we convert V to equivalent Vp, flow rate under ideal condition, equivalent flow rate under ideal condition in passenger car per hour per lane. So, the Vp value is known. Once the Vp is known, we can check whether this value is more than the capacity or not. If it is more than the capacity, then straight away we will say the level of service F, capacity is 2308 and Vp is 1142. So, Vp is less than the capacity, therefore, it is not always safe directly based on volume to capacity ratio or demand to capacity ratio greater than 1. So, therefore, what we have to do? We have to calculate the density. To calculate the density, we will again use this equation 4.1. So, those equations are there. We know that up to break point it is something and then beyond break point it is something else. So, that equation we have brought it here. So, what is first is the break point, that equation is used to calculate the break point value, because up to break point the speed is free flow speed. So, break point flow level is 1568 and what was our flow rate? 1142. So, it is volume is within the break point. So, therefore, the free flow speed itself will be there 60.8 mile, what we calculated earlier. You can see here 60.8 is the FFS adjusted, that is what. So, same value will be there because it is within the break point flow. So, once it is done, then we know we can calculate the D. So, the Vp is 1142, S is because it is within the Bp value, Bp is 1142 which is less than this Bp flow, breakpoint flow of 1568 and we know up to breakpoint the speed is same as the FFS or FFS adjusted. So, you can calculate the density and you calculate the density as 18.8 passenger car per mile per lane. So, once you know that, then 18.8 comes under where? Greater than 8 and up to 26 in that range. So, that is level of service C. So, we say density is 18.8 passenger car per mile per lane and level of service is C. So, that is one application how we can apply for basic freeway segments. Example 2 is on multi-lane highway segments. Let us take this example. What is the expected LOS on a 5-lane highway, 2 travel lane in each direction plus a 2-way left turn lane? In Indian condition, it is almost like equivalent to a right turn lane in each direction with the following characteristics. Lane width 12 feet, traffic composition 6%, posted speed limit. Yes, this has got some relation. To get that BFFS, basic free flow speed values, we can calculate once the posted speed limit is known. 50 and above one formula, less than 50 another formula. So, it less than 50 case. So, we can apply this, this is important. Access point per mile, yes, not the RAM density in this case, but it is access point per mile, but then it is separate for eastbound and westbound. So, we have to do the calculation separately for the eastbound and westbound, because the access point per miles are different. Lateral clearance both sides of the roadway 12 feet, quite adequate. Commuter traffic is regular users. Median type 2-way left turn lane as it is told here, peak hour demand 1500, rolling terrain and it is peak hour factor 0.9. So, mostly all the inputs are given, and here since the no base FFS is given. So, from the posted speed limit we will calculate, and in this case it will be posted speed limit plus 7 mile per hour. If it is 50 and above, then it is posted speed limit plus 5 mile per hour, but in this case 7 mile per hour. So, we get BFFS as 52 miles per hour, and then we have to check if all these corrections are applicable. Lane width, first check it, lane width it is already 12 feet, yes. So, this correction is 0 as per the table, because adequate lane width as per the base condition is available. So, no further correction. Then next F TLC, that we have to say total lateral clearance. Now, total lateral clearance is lateral clearance left side plus lateral clearance right side, but in each case you have lateral clearance 12 feet, and we know that the maximum value is 6 feet. Even if 6 feet and above, no correction is required, that is adequate. So, 6 plus 6 12, and so here also that correction is 0. So, lane width and correction is 0, and also the TLC, the total lateral clearance correction is 0. Then FM, FM is what? FM is the median type. Now, let us look at this median type table. It is TWLTL. So, it is again 0. So, median type adjustment is also 0, and what is remaining now is the FA, that is adjustment for access point density. Now, let us go to an appropriate table for calculating the access point density. So, in one side we have like eastbound it is 10. So, eastbound there will be reduction of 2.5 mile per hour free flow speed, but westbound it is 0. So, separate value, earlier all the same, but now here it would be different for eastbound and westbound. So, one case we have to based on the access point density, one case we have to reduce the free flow speed by 2.5 mile per hour, and another case it is 0. So, therefore, the FFS free flow speed eastbound would be 52, these 3 components are 0, and here it is 2.5 for the eastbound. This is the only correction that will be applicable in the present example. And for westbound, no correction, because here also westbound is 0. So, the access point density is 0. So, here it will whatever will be the basic free flow speed. So, free flow speed will be same for the westbound. Eastbound it will be reduced by 2.5 mile per hour. Now, estimate and adjust capacity. So, we know we can take it from the table also or exhibit given in highway capacity manual, but in this case we are calculating it from the equation. As we calculated it in earlier case example 1, you remember the example 1 we calculated it using this equation, but that equation was for basic freeway segment. For multi-lane facility, the equation is different. So, we took this equation and here again because the FFS free flow speed adjusted one is different in eastbound and westbound. So, the capacity also we have to calculate separately for eastbound and westbound. So, eastbound it will be 1900 plus 20 into 49.5 minus 45, and westbound case the all this will be 1920, but this will be 49.5 instead of that it will be 52 for westbound. So, you calculated capacity, what we got is 1990 for the eastbound passenger car per hour per lane, and for westbound it is 2040 passenger car per hour per lane. So, the capacities are calculated. Now, the adjusted volume, as you know the V p equal to V divided by peak hour factor into N into FHV. So, the V is here 1500 vehicle per hour, it is vehicle per hour, peak hour factor is given as 0.9, number of lanes in analysis direction is 2, and FHV heavy vehicle adjustment factor that we have to calculate using this. So, we need PT value and ET value. So, the PT value is known, that proportion of heavy vehicle is 6% and ET for rolling terrain I mentioned it will be 3. Let me go back. Here we said that this ET will be 2 for level terrain and 3 for rolling terrain. So, since it is rolling terrain, so we take this ET value as okay. So, that is what we take the ET value here as 3. So, applying this again we calculate the FHB eastbound, and here in this case since the free flow speed is not coming into picture. So, the FHB EV eastbound EB, and for this correction for heavy vehicle for the westbound would be same, and that F value is 0.893. So, now we can calculate what is the V p equivalent hourly flow rate in passenger car per hour per lane, eastbound and westbound will be same. So, 1500 divided by PHF 0.9, number of lane 2 and this FHP 0.893. So, you get 933 passenger car per hour per lane. Once we know that, then we come to this equation, what would be the speed, because we know that it is we have to check first whether it is less than BP or so. So, the BP here is calculated as 1400, highway operators with constant speed portion. So, therefore, speed will be actually same as free flow speed, because this is the flow rate which is less than the or the demand equivalent demand under ideal condition is less than the BP value. BP for multi-lane highway it is fixed 1400. So, earlier case for freeway we had to calculate this, but here it is 1400 fixed. So, it is less than BP flow rate. So, we know that speed will be equal to FFS. So, then for eastbound it is 49.5 and for westbound final speed is also 52. So, then we can calculate the value of D, the density. We know the V p, we know the S for eastbound and for westbound. So, two cases the density we have to calculate separately. So, eastbound density will be 933 divided by 49.5. So, 18.85 passenger car per mile per lane, and for westbound the density will be 17.94 passenger cars, because it is 933 divided by 52 instead of 49.5 as it was for the eastbound direction. Westbound direction it is 52. So, the value is 17.94. So, now we can see, first go to the eastbound 18.85. So, 18.85 comes in this range, which is corresponding to C. So, we can say for eastbound the LOS is C. For westbound it is 17.94. So, 17.94 is actually greater than 11 and up to 18 in that range, because it is 17.94 actually less than 18. So, for westbound the LOS is B. So, that way we can calculate. So, what we discussed in this lecture, this is the last lecture. We had 3 lectures to do the capacity and analysis of LOS for freeway and multi-lane highway segments. So, in this lecture we discussed, we started in the last lecture also with this operational analysis methodology, the 6 steps. We again started with that overall 6 steps, a brief outline, and then step 1 and step 2 we discussed in details in our previous lecture. So, in this lecture we discussed the other steps, step 3 to step 6, what exactly and how we do the computations, right. And then we took 2 example problems, one with freeway segment, another example on multi-lane highway segment, to show you how we can actually do the operational analysis, do all the computations every step, and eventually calculate the level of service. So, one example we took with the free flow with the freeways and segment, and another example with multi-lane highway segment. So, with this I close this lecture, and thank you so much.